Hi everyone, I'm here with Ted Mebane, one of the winners of the Geotab Vibe Coding Hackathon, and we're going to review his project and how he managed to become this big innovator. How are you doing, Ted?
I'm good. How are you doing today?
Good. Uh, First of all, congratulations for getting one of the big prizes from this hackathon. How did people at your work, home react when they learned about your winning?
It was a great honor to be recognized for something that was a real problem that I noticed in our fleet, and take that problem and create a tool that you see in front of you. My fiance was extremely excited, and everyone at work was giving me pats on the back and saying what an awesome idea it was. And I'm glad that other people and the judges recognized that value that I built and the tool that I built.
Exactly. So, what's your day-to-day job, and what was this problem that you kept seeing?
My day-to-day job at Excel Energy is sort of their telematics administrator. So making sure all the data coming from our vehicles is valid and boiling up to our various different reports, safety and all those normal reports that you sort of get along with your telematics data. And one of the problems I kept running into was understanding the right sizing of the fleet and understanding what vehicles can you get rid of. And something I noticed at Geotab Connect in one of my breakout sessions was the need to understand how can I get rid of vehicles based on utilization. And a lot of the tools that exist out there for right sizing are based on low utilized vehicles. So looking at what vehicles are underutilized in your fleet. And one question that I had was, well, what if we approach this problem from a different perspective and asked instead what vehicles are not needed at the same time in the fleet versus what vehicles are not needed? And that's sort of what this idea for PoolFinder was born out of, was trying to answer that kind of next step question beyond what vehicles are underutilized and answer the question of what vehicles are not utilized at the same time and could potentially be brought into a pool and reduce the overall amount of vehicles. So this is something I notice every day in our job at Excel Energy is, we've got 5 departments that each have their own vehicle, and perhaps they don't use that vehicle at the same time. So is there an opportunity to take those 5 different departments and take their 5 vehicles and get rid of 2 of them and have 3 in a pool that they could take out as on an as needed basis, um, and effectively reduce the number of vehicles in your fleet, which obviously has a correlated um, cost savings.
That's a great idea because instead of just looking at the number, this is utilization of this vehicle, we can look at all our vehicles and try to fit how do we share the same vehicles with more departments. But it's very easy to say that. It's very easy to see one or two examples. It's not that easy to run it at scale. How many vehicles are you working with?
So in this test demo database, I'm working with 50 vehicles. At Excel Energy, we have about 8,000. So a lot more vehicles. So that was part of the experience with coding this, was understanding what's the most efficient way to do this kind of analysis, because obviously comparing even just 50 vehicle schedules against each other is a lot of computational load. And as you see that number up there, over 11,000 trips, if you're in a big fleet with 500 vehicles, you could have, upwards of 500,000 trips in a 90-day or 1 year period.
Let's start the demo, but before we start it, just as context, um, we're going to see a front end, we're going to see algorithms, we're going to see like this working at scale. Uh, how many times have you done this previously? What's your experience?
I had no experience with HTML coding. I had no experience with building algorithms. I have some level of experience with Python analysis. My Geotab HTML add-in was completely foreign territory to me.
So let's look at the demo, and we can all marvel that you were able to do this in a couple of days just by asking questions to Claude.
Yeah, so this was built over the course of one weekend, actually, a long weekend for me. It was a holiday weekend, and it started out with just that idea. I think my first message to Claude was I want to build a tool that looks at pooling opportunities for fleet vehicles. And we sort of built from there. So, as you can see here, the first thing you look at when you open up the tool is the amount of vehicles analyzed, the number of trips modeled, and the complementary pairs that it found. So that's actually the first step to the algorithm is this cosine similarity score.
Whose idea was to use cosine similarity?
So the cosine similarity score was a direct output of Claude. I asked Claude essentially what is the most efficient way programmatically to find vehicles that don't have the same utilization pattern. And it, after doing a little bit of research and thinking, it came out with that the cosine similarity score is the fastest way to measure the overlap between two schedules.
I've heard about cosine similarity. Maybe I've used it at school, but I would have never thought to use it for this. And Claude is like, oh, this is exactly the smallest tool that will solve your problem.
That was one of the big things that I noticed with Claude, and one of the things that I was extremely impressed by with AI was its ability to understand the problem I was presenting it with and return back, hey, cosine similarity score would be a great way to quickly identify which vehicles don't have overlapping schedules.
So, okay, we're doing that math, and how does that look in the UI?
Yeah. So you can see up here there's a number of quote unquote complementary pairs. And what the complementary pair is, if you scroll down here, we can actually expand this matrix and see what complementary pairs it had. So we can see demo 5 and demo 12 are both type van and both in the same location, and they have a 0% overlap in their schedules. So it builds out the cosine similarity score, gets you what vehicles don't have overlapping schedules. And then, of course, the next question is how can I pool those together into larger pools of vehicles? So obviously, in a real world environment, saying you can get rid of one of these vans and out of these two vans and only have one of them and they don't have overlapping schedules is a little bit less valuable than the ultimate recommendation, um, as you can see up here, of saying you've got 5 vehicles and you can actually reduce those to 2. So that was sort of the next step in the algorithm, and that was after I established that we built the complementary pair matrix with Claude. I asked it, okay, how can we take this the next step and build out these pools versus just complementary vehicles? So you can see it actually found 103 different complementary pairs and then built that out into 6 different pooling opportunities.
I can see, at least in the simulated data, you started with 50 vehicles, and you can tell management that they can do without 14 of these vehicles. That's a major savings.
Yeah, absolutely. And this was born out of something that I observed and I kind of mentioned previously, which was that each department has their own vehicle. They're not communicating with each other. If you're looking at the utilization, you might see, oh, these vehicles are being utilized by each department. But what you might not see is that one department operates from 8 a.m. to 12 p.m. and another department only operates from 2 p.m. to 6 p.m., for example. So that's sort of what the tool was built around, was understanding how can you sort of take these different departments and different operations and consolidate them into having less vehicles. So this is all built off of demo data. So the 50 vehicles analyzed were a variety of backhoes, vans, and pickups at 2 different depots, Depot North and Depot South. And those vehicles were assigned shift-based scheduling based on the type of vehicle. So pickups were assigned sort of um, sporadic shift use patterns. Vans were assigned a similar pattern, and then backhoes were sort of established on a project-based schedule. So that's sort of how I built out the demo database to reflect a real-world mixed-use fleet. So you can see the first recommendation. And I think one of the key things that I wanted when I was working with Claude was not only the recommendation, but also the data behind the recommendation. Um, I think going up to a fleet manager and telling them you can get rid of 3 vehicles is great, but you might not have the data to back that up. And a fleet manager wants to know, can I operationally do the same amount of work with less vehicles? So that's sort of where these recommendation cards and the data that's in them were born out of, was in a real world environment. You want to know for a fact that you can get rid of those vehicles based on data. You don't want it to be like a gut feeling that, oh, I don't need this vehicle. And that's where sort of the cards, the recommendation cards that you see here, were built out of. So it, breaks down exactly the 5 backhoes, how much you can reduce it to. These are backhoes in Depot South, so they're the same type of vehicle, they're in the same location. And it has this short blurb about why exactly this works. So across the full calendar window, these 5 vehicles never exceeded 1 vehicle in simultaneous demand. PoolFinder then does a round up. I think in a real world operational sense, you don't want to go down to the minimum amount of vehicles you need. You want to have that little bit of buffer. So that's where sort of that buffer was taken from, was understanding in a real world operational setting that you're not going to get rid of down to the bare minimum. You want to have that kind of extra buffer vehicle or 2 vehicles in case one goes out of commission, it gets in an accident, you can't use it anymore. You don't want to suddenly be floundering and saying, oh, well, now we don't have an extra vehicle. So that's where that buffer sort of came out of, was my real world observation that sometimes stuff happens and you do want to have kind of that safety room in case anything does happen. So
Yeah, this goes beyond the algorithm, but understanding this is how people work.
right.
And this is the kind of safety we need. It's not just optimization. You need to be able to do the work when the vehicles need it. Otherwise, people will get angry to whoever recommended to get rid of 3 of the 5. I mean, this is simulated data, but you told me that since the hackathons has been over, you have still been developing this because now you're testing it with real data. How is it, the real world test going?
It's going really well. So I actually ran this on our own fleet and um, on a kind of subset of data. So I only ran it on one depot and I ran it on automobiles. And it actually found that out of 47 automobiles at one depot, you could safely get rid of 20 of those, resulting in nearly $500,000 in estimated savings between capital savings and annual operational savings. So that's one of the things I actually added to the tool, was this configuration screen. So what this allows you to do is define your vehicle types, and these are taken directly from your groups in Geotab. So I created a backhoe group, a pickup group, and I was able to assign those vehicles to those vehicle types as groups. Same with the depots and location. And you can see I actually added on a 365-day analysis. Sometimes 90 days isn't enough. If you're operating a very seasonal fleet, you might want that full year of data. And actually, you can see down here, you can define that you want those simulated patterns that I'm showing you now. But you could also switch this over to pull real trip history data from the Geotab API. So what that does is it pulls the trip history data for each vehicle that you defined in your depots and in your vehicle types. And it does the same algorithm, except it's on your real world data versus the simulated data. So, like I mentioned, I actually ran this on a subset of our own fleet, automobiles in a specific depot, and it identified 20 vehicles that could be safely eliminated because they're never utilized at the same time. So that was a big deal for me, going from simulated data to actual real world data in our fleet.
Yeah, beautiful. I'm just thinking how this is such a big change on how we interact with the world now. Like on one hand, you never done a project like this, and now you're able to pull this off. So there, you must have learned important lessons of working with AI. But at the same time, you have a job, you go there every day, and now you're doing something that you never done before. And there are lessons of how do we adapt the workplace to people now being able to do things they were not able to do before, and optimizations are coming from places that we were not expecting them. But still, there's a human side to this, human conversations. How, what lessons have you learned on both sides, on using AI and then on using the results of AI within a workplace?
Yeah, yeah, absolutely. That's a great question. I think that AI, at least the way I approached it, was almost having this business partner that knew every coding language and every mathematical
Mm-hmm.
algorithm. And what I did was I almost approached this partner with this idea of a pooling analysis. And what I was able to do was kind of work with AI, almost like I mentioned, like another business partner, to understand how can I build this in the Geotab environment as an HTML add-in? How can I, what algorithms and mathematical equations should I use to assess utilization? I think one of the big things that I learned in this journey was, as I mentioned kind of previously, just how powerful AI is in terms of that reasoning. So, like I mentioned, I had no idea what Bron-Kerbosch click detection was, but by describing the problem to AI, it was able to make that recommendation for me. So, I see, at least during this process, I kind of saw AI as a tool to be utilized to improve my skills. So I had never coded an HTML add-in or worked with JavaScript, but it was able to take my idea, refine it, define what mathematical equations I should use, and then build this application for me. So I approached it with an idea, and it was able to take that idea and build it into what you see before you, which previously, before the conception of AI and its widespread use, was, practically impossible. I mean, if I wanted to build something like this, I would have had to learn HTML, learn JavaScript, understand the data, research what mathematical algorithms. I mean, it would have probably taken me, years to build something similar that with AI I was able to build in one weekend. So I think that is the huge power of AI, is its ability to take, quote unquote, ordinary people like myself and almost turn them into developers, and build things that otherwise they wouldn't be able to build. I think a lot of people who don't necessarily have development knowledge might have similar ideas pertaining to fleet or in any industry. They have a really good idea, but how do I take that good idea and build something? And I think previously, before AI, it would have been impossible. And now with AI and its ability to both code and understand and reason,
Mm-hmm.
you're able to take something that's an idea and build it out into what you see before you.
Yes, and then how do you apply that at work? Because now you're working with people and you're telling them, "I've done something that I've never done before. I've done something that is not part of my job description." How we do fit that in a workplace?
Utilizing AI in my day job, I think that the big use of it is improving efficiency. So something that would have taken a couple hours to do can now be reduced to 10 or 15 minutes, say. And I think that is the big advantage of AI in a normal workplace is I mentioned, taking ideas and making them reality, but it's also just automating and improving the efficiency on those smaller tasks. So an email that might have taken you half an hour to write now only takes 5 minutes with AI. Um, so that's how I'm largely utilizing it in our workplace is just to improve efficiency and to kind of bounce ideas off of. I mentioned that business partner relationship with AI that I sort of had during the development of this tool. And I think that's a great way to utilize AI in your workplace is sort of as this all-knowing other business partner that has all of this knowledge that you can bounce ideas off of and understand where you can improve processes and have it, obviously help you write emails, but also how do I optimize this process or what would be the best way to approach this analysis? I think that was something that I noticed in my tool, and that I notice in my day-to-day job is understanding the current process and bouncing that off AI and how do I make this more efficient?
Yes. By the way, I could be talking all day to you here, and your GitHub repository is incredible because people can see exactly how you develop this. There's a great architectural diagram of all the steps PoolFinder uses to find these pools. Um, let's not review that now, but for people that are interested and want to go there, uh, what's your summary of what they will find in your GitHub repo that's interesting to look at?
Yeah. My GitHub repo and the README in there really goes through the entire process, kind of from the conception, my first message to Claude, to the final product that you sort of see in front of you. So it outlines, like you mentioned, that architectural diagram of exactly how the algorithm is working behind the scenes. But it also dives into why I built this and what the real world operational use is for this tool and what I was noticing other industries were having challenges with, and other fleets kind of in the same wheelhouse as us. So the README sort of dives through not only the first chat to Claude, but also the conception of the idea and the understanding of the real world problem. And then it also dives into, my exact history with Claude. I've got a link there to the full conversation if you're, willing to go through probably upwards of 200 different chat messages with Claude. But it also touches on some of those highlights, like the prompts I use to first present it with how do we take the complementary pairs and go to a pool opportunity and it returning, oh, Bron-Kerbosch algorithm would be a good application to build this around. So I think it has a ton of great information, not only about the capability of the
Yeah.
tool, but also my building process, which I think is really helpful for people who are looking to learn more about what AI is capable of doing and kind of taking a look at how I built this with AI and understanding, oh, it can do that, or it can understand an issue
Yes.
and apply an algorithm to it.
If people want to learn more about what you built here, there's a GitHub repo, there's a LinkedIn. What would you like people to remember from this conversation and to do next?
I think that if you're gonna take away one thing from this demo, it would be to check out that evolution of the conversation with Claude and really understanding what was happening behind the scenes. You see this beautiful UI that Claude helped me build in the algorithm, but it really took, like I said, between 100 or 200 different chats to get to what you see before you. So I would say that is one of the biggest things to take away from the GitHub and this project in general is AI can help you and it can really do a lot of cool things, but you have to really iterate and approach it as a business partner kind of relationship.
This is great. Thank you, Ted, for sharing with us. Thank you for participating in the hackathon and congratulations for winning. Hopefully, I'll see you down the road.
Absolutely. Thank you for having me today. And yeah, if you do want to learn more, just feel free to reach out to me or watch for the demo video.
Excellent. Thank you, Ted. Have a great day.
Thank
And
you
thank you,
too.
everyone, for watching. Like, subscribe, comment. We love learning what you learn from this video and from this process. Thanks.